Now that we know how to solve polynomial equations, we want to change it a little bit and be able to solve polynomial inequalities. So when we go to solve these polynomial inequalities, it's very similar to solving a polynomial equation. It's just got some extra steps. So the first thing that we want to do is we want to make sure that everything is on one side of the inequality. Once we have the entire expression on one side of the inequality, we can determine if that equation is going to be greater than or equal to, less than or equal to 0. So 0 is the same number that we were using when we were solving. So now the second step is we want to solve it as if it were a regular equation. So we're going to solve it and graph it. So everything that we just did with the solving and the graphing, we're going to go through all of those steps. Okay, so we're going to set it to 0. So we might have to move some stuff around. Then we're going to solve and graph. Okay, so what we want to end up at this point is we want to end up with a number line here and some sort of a graph that we're looking at, okay? So this is the idea of where we're at. So we had some equation and we got it set to 0. So let's say that it looked something like this. We have some equation, whatever it is. We've set it greater than or equal to 0. So we've moved everything to the right, to the left side of the equation. And now we see that it's greater than or equal to 0. I went ahead and solved, found what the x's were, put them on my x-axis, found the end behavior, connected, did my smooth curve. Now I'm ready for the new part of this solving. Okay, so an inequality now means we're going to take this and we're going to add in boundaries, okay? So what I mean by that is, what we want to do is we want to think about these x values, these x-intercepts, as a boundary, and we're going to kind of partition off this graph, okay? So now I can see that there's one part here, another part here, another part here, another part here, and then one part there, right? So if I'm looking at this graph specifically, I would see that there's 1, 2, 3, 4, 5 parts to this graph, okay? Now, that's what I mean by we're going to section off the graph, drawing vertical lines through those solutions. Okay? Now, each section, what we are going to do is we're going to look at that graph and we're going to decide, is the graph that we have above or below the x-axis? So thinking of our x-axis here, so here's our x-axis, right? We have to ask ourselves, when we are on this section, we are below, all right? So I'm below the graph, so I'm going to put a little negative, or I can put the letter B. All right, so anything that is below that x-axis, I'm going to do that too. So I see another piece here and another piece here. Okay, so I've got 3 pieces where I'm up below, and then I have a piece here and a piece here where I am above. So I'm going to put a plus and an A, a plus and an A. Okay, so I'm either below or I'm above that x-axis. Remember, the x-axis is treated as our y equaling 0 in an equation. Okay, so if y is equal to 0 here, above would be that we are greater than 0. Below would be that we are less than 0. Okay, equal means just that we're going to use a bracket versus a parenthesis. Okay, so when I look back to my function, now I'm going to go and I'm going to say, okay, well, what does this inequality really say? Well, my inequality here says that I am greater than or equal to 0. So greater than 0 means that I'm going to keep this piece because it was above, and this piece because it was above. Okay, so that's what I mean by we're going to look back at the inequality and decide if we're going to keep any above or if we're going to keep any below. Then once I'm done, I would write my inequality as an interval. So the solutions will be written as an interval. And remember, with an interval notation, in our case, we would be using brackets because we've got an equal sign underneath. If there was no equal sign, we would be using parentheses. Okay, so let's look at an example all the way through and see if we can work through it here. All right, so first example, let's say that we have the equation, or inequality, x squared minus 5x greater than or equal to 24. All right, so the first thing that we want to do is we want to move everything to one side. So I'm going to go ahead and move over this 24. So I'm going to move it to the other side. So we've got x squared minus 5x minus 24 greater than or equal to 0. So this right here is the step that I'm most interested in going back to, because this is going to tell me right here what my inequality is. So when I look at that inequality, what that's going to tell me is that I'm going to keep things that are going to be above with the plus, and I'm going to be using brackets. Okay, that's what I will have for the end of my answer, right? When I get to the end and I go to write my answer. Okay, so now the question is, well, what is the graph like? Where are the spots that I'm above versus below, and what are the x values? So to do that, we need to solve and graph. So I'm going to solve this polynomial here. Okay, now I know how to factor this polynomial, so I'm going to go ahead and factor. You could make a rational list and do all of those things, and we'll do one like that in the next example. So I'm going to go ahead and factor. The numbers that multiply to negative 24 and add to 5 is going to be a negative 8 and a positive 3. So remember, I'm going to set each equal to 0 and solve it. So x is going to equal 8 here, and then x is going to equal negative 3. So I'm going to take each of these numbers, I'm going to put it onto a number line here. So I'm going to say negative 3, and I'm not going to use a whole lot of numbers on my number line. I just need to get an idea of where it's going to be. Now I need to connect that with my end behavior. So my end behavior means I got to take the a and I got to take the n. My a is going to be a positive. My n is even. So a positive even is going to go up, up. All right, so I'm going to put those points on my number line here. Neither of them repeat or have a multiplicity, so that means they're going to cross each time. So I'm going to go up here, up here. I'm going to cross through, make a turn, and come back and cross through. Since my n was a 2, that means I should have one turn, which I do. Right? So now I know that my graph is correct. So all of that is that step 2, solving and graphing as if it were an equation. So now what I'm going to do is I'm going to go through and I'm going to section off my graph. So to section off my graph, I'm going to draw a little line here, draw a little line here. So I've created 3 sections, one section here, one section here, and one section here. So now that I have my 3 sections, I need to determine if those sections are above or below. So I look at my graph and I see that this section is above. This section is below. This section is above, right? So now I need to go back and I need to look at what we said we were going to keep from our original equation here. So we determined that because this inequality was greater than equal to, we were going to keep the above, which was positive, and we're going to use brackets. So I'm going to keep these above pieces here. So I'm going to keep this piece, and I'm going to keep this piece. So think about whenever we were writing an interval. If I was equal to, I would put a bracket or a closed dot here and a closed dot here. So let's write this as an interval. I'd be going from negative infinity all the way to negative 3 with a bracket Now I use parentheses when we're talking about infinities always, so that doesn't have anything to do with my inequality. Then I'm going to jump, make a union. I'm going to start at 8 with a bracket, and I'm going to go off to infinity. Okay, so I used those outside pieces because they were my above pieces. I used brackets because we had an equal sign. Okay, so that's what the entire process would be to find my final interval answer. Okay, so we're going to look at one more example here just to make sure that we've got it, because there's kind of a lot going on here. So let's say that we had the inequality 2x cubed minus 15x squared less than or equal to negative 24x minus 16, right? So when we look at this, the first thing that we want to do, I kind of wrote it weird there. The first thing that we want to do is we want to get everything on one side of the equation. So I'm going to go ahead and I'm going to move everything to the left. So I'm going to add that 24x and add that 16. All right, so my equation is going to be 2x cubed minus 15x squared plus 24x plus 16 less than or equal to 0. Okay, so now this is the equation, or excuse me, this is the inequality that I'm going to be using for the rest of my problem. So looking at this, the first thing I'm going to do, I look at this inequality and I say, okay, well, what should I keep in the end? I am going to keep my, if I'm less than, I'm going to keep my below, which is my negatives, and the equals means that I'm going to, again, use a bracket. Okay, and we'll save that for later. So now what I want to do is I want to actually solve this. So to solve this equation, I don't know how to factor it. So instead what I'm going to need to do is I'm going to need to make my list. So I'm going to have plus or minus 1, plus or minus 16, plus or minus 2, plus or minus 8, plus or minus 4, divided by plus or minus 1, plus or minus 2. So when I start to divide these, I get 1/1 half, 16, 8. 1's on there. I get 8. It's on there. 4. Remember, all I'm doing is I'm taking each value, I'm dividing it. So 4's on there and 2's on there. So this would be my numbers that I'm going to go to the calculator, plug in. I'm going to go use synthetic division, whatever you want to do. And what I will find after plugging those in, so I would find that I would get 4 to work, and I would get -1/2 to work. So I need 3 solutions, but I only found 2. So the question is, one of these must repeat. So what I need to do is I need to try these numbers more than one time. I know one of them has to repeat at least once. So me, I like the whole number, so I'm going to use 4. So I'm going to do synthetic division with 4. So I got 2, -15, 24, 16. Now I better get a 0, right? Because I know for sure that it works one time. So I'm going to get 8 here. I'm going to get -7, -28, gives me -4, -16, 0. Perfect, I got it. Now the question is 4 the one that repeats? So I would need to try 4 again with my new numbers. Let's bring it down. I don't need the 0 anymore, right? So I'm going to bring down the 2. And the question is, do I get a 0 again? If I get a 0 again, then the 4 is the one that repeats. If I don't, then it must be the -1/2 that is repeating. But I know one of those numbers must have a multiplicity. They must be repeating. And what I notice is, look, I get a 0 again. So what that means is that 4 has a multiplicity. So x is going to equal -1/2, and x is going to equal 4 with a multiplicity of 2. Now remember we said if it's got a multiplicity of 2, what's going to happen is when I graph it, it's going to sit versus cross. Okay, so I'll get a little bit more room here. Now, I'm going to go ahead and go make my graph here, and we'll see what I'm talking about. So I go graph this. I need my end behavior, so my A, which is 2, so that's positive. My N, which is 3, which is odd. So a positive odd is going to go from down to up. So I'm going to put my numbers on there. I'm going to have a -1/2, and I'm going to have a 4. Remember, I don't need it technically drawn to scale here. I just need to be able to connect it. So I know that at -1/2, I'm going to have an end behavior of down, and at 4, I'm going to have an end behavior of up. Now, a multiplicity of 2 here means that at 4, I'm going to sit. It's going to represent a turning point. So as I cross through at 1/2, it's going to go back and it's going to turn around at 4 because it's got a multiplicity. It's going to sit and turn versus cross. So my graph would look something like this. All right, so this one was a little bit unique. That's why I wanted to try this one. Okay, so now that we've got our graph going on here, I'm going to section it off. Again, I've got 3 sections here. All right. On each section, I'm going to determine, am I above or below? So here I am below, here I am above, and here I am above again. All right, so I've got those 3 sections. Now I've got them labeled. So I go back up and I say, okay, here we go. I want to keep below. I want to keep the area that is below. So I want to keep this space over here. And I want to use a bracket. Okay, so let's see if we can write our answer. I want to keep this area that is from -infinity to -1/2. Parenthesis always for an infinity, and then this -1/2 is going to get a bracket. So my answer would look something like that. All right. So when we're doing these polynomial inequalities, the good thing is that it's only one extra step to solving and graphing. However, I have to solve and graph. I have to do all of that just to get to that final answer. So I'm going to start off. I'm going to set everything on one side of the inequality symbol. I'm going to determine, using that inequality symbol, what would I be keeping? Will I be keeping above or below? Will I be using a bracket versus a parenthesis? And all that is looking at that inequality symbol. Then I'm going to solve and graph. So whatever that means. Does that mean that I factor it? Does it mean that it's already factored, so I just set each thing equal to 0? Does it mean that I have to make my list and try all of my answers? We don't know, okay? But we'll do some type of solving, get our x values, put them on the number line, connect it to the end behavior, so I'll have to go find that end behavior. Connect it to the end behavior, do my smooth curve depending on the multiplicities if I'm sitting or crossing. Then I'm going to go back and look at, okay, well, what am I going to keep? Do I keep the above or the below part? I'm going to shade the spots that I'm going to keep, and then I'll write my answer as an interval using the brackets or the parentheses that we had decided on based on the inequality.